Hello again. I'm back. I'd like to finish what I started. And though many of you are not watching this live, I know you're watching this afterwards, and I know that you will appreciate it. I was able to stabilize my network. If you could, let me know if you can hear me. My last concern. We did have problems before. It seems that things reset. Looks like it's picking up. You can just let me know if you hear it. Okay. So because we got cut off in the last chat or the last live stream, because we got cut off, we lose the chat when we get cut off like that. The captions will still appear, but the chat was compromised. So let me try and pick up where we left off. If you have questions after watching this video, please contact me and let me know. So we left off, what we were going to do is enter this data into Excel and compute the mean. So the mean is just an average. So an average can be computed in Excel. I'm just going to check one thing. Yes, it's working. Okay. Let's do that. So I'm going to open Excel. This is where I noticed I had problems because it wasn't connecting. It wasn't connecting because I had no internet connection. Okay. Allow me to adjust the screen just a bit. Okay, to enter this into Excel, let me see if I can make this bigger. Yes, I can. And I'm going to enter the data for, I'll put a heading on it. So this is for Maris. Okay, what do I need to do? There. And the data are 14, 28. I'm reading right from the sample problems document. 16, 39, 61, 33, 23, 26, 8, and 13. For a total of 10 observations. And all I need to do to get an average, I'll make this smaller again so you can see what I'm going to do. So I'm going to invoke a function by pressing equals. You can see it in the bar above here too. Okay, so I press equals, and then I say average, and I can choose this symbol over here. I don't know if you guys can see that. The summation symbol. This is for sum. But what I want to do is the average. Sorry, that's not going to give me it. I want to average. Okay, I can pick average. It'll do it automatically. But it doesn't enter the value for me. Okay, let me fill that in. Okay, so average is what I wrote. And then what I want to do is highlight this data. And the way that I do that is I touched it, and then I pull down to include all the data, and I press enter. And that gives you the average. If I entered the values correctly, Let me double check. 14, 28, 16, 39, 61, 33, 23, 26, 8, and 13. Okay, so that's the average. Oops. So what we can do with that information is return to here and write down that our average, because I did Maris's average. Okay, let me talk about that. So now let's do Ruth's average, okay? I entered Maris's average. But what I wanted was Ruth's average. Let's put that in. So for Ruth's data, there's more. $54, $59, $35, $41, $46, $25. Now you could also enter this in the order of the stem and leaf plot. I'm just pulling it from the original document. 25, 47, 60, 54, 46, 49, 46, 41, 34, 22. All right, so 54, 59, 35, 41, 46, 25, 47, 60, 54, 46, 49, 41, 34. Okay. Doing the same thing. I calculate the average for Ruth, and you can see it's clearly higher. So these are home run hits. I recommend, in terms of summary statistics, to hold 2 more decimal places than the original values you had. However, I present both. I'll present 43.93, and then I'll also present 44 hits. Okay, so let's put that now into the document. So for the sample mean, we got X bar equals to 40. Now I'm going to forget 43.93. I have to check again. Should have written down. Yep, 93. 43.93, 2 more decimals than original, but this is approximately 44 hits. Okay, so that's quite high when you compare it to the mean that we got for Maris, 26.1, much higher. However, we're comparing then averages, but is average the correct measure of expected value when the data are skewed? In fact, it is not. So I have an explanation of that in the notes. I want to go to that explanation. Okay, so there are actually 3 measures of the expected value. Actually, I mentioned 4 in the notes. Mean is the more popular. People will take a list of numbers and just calculate an average as though it's meaningful. The average calculation will give you the center of gravity. It will give you the balancing point for the distribution you created. So if the distribution is skewed, that's not going to make, this value will not be a good measure or center of distribution. This value, where the peak rests, will not be a good measure of the center of the distribution or center of gravity, because in both cases, it will tip the distribution. You aren't really finding the balancing point. The balancing point will be somewhere like here. That's where this weight here, so this mass, which includes the values and their frequency, so that values and deviation from the average and how often they occur, is outweighed or balanced by these observations with there's less frequency or less occurrence of these values, but because the values themselves are so high, it balances this shape. So it's clear that the mean takes into consideration how many observations of a certain value you get and the actual value itself. Okay, so that goes into the calculation, and that's what creates this effect that you're getting the center of gravity. Now, if a distribution is symmetric, as we have here, the balancing point would be here, A. It's where you have a few observations, so you have most of the observations around the mean. You have a few observations higher, but just as many lower. You see, it's like a mirror. Then you have a few even higher, but just as many or just as few even the same distance lower. So in this way you have a mirroring through the mean, and which it also happens to be the modal class. The modal class refers to the class where the peak is. Remember, there's classes under this density curve that I've drawn. So it turns out that in a symmetric distribution, the mode and the mean and the other measure of center that we're going to talk about are all located in the same place, roughly. It's in a skewed distribution where there's some difference. Okay. So with that in mind, what would be a good measure of expected value for this distribution? So that if we calculate the mean, we got 26.1. 26.1 would be about here. Now, if we were to balance the distribution here, do you think that would be a good balancing point? Do you think the distribution would balance here, or would it be more likely to topple over? It turns out that we can check this. It will it will, in fact, the center of gravity from distribution to distribution is it's always going to be where the mean is. Okay, that's the center of gravity. However, is that a good, the question is that a good measure of expected value? So is there a difference between the center of gravity and the expected value? It turns out where I will refer to, in this case, this is kind of the shape that we're dealing with, right? So A represents the mode or the modal class. It's the most frequent class where observations fall. It turns out that the mean will be located, for balancing purposes, the mean will be located in a position closer to the extreme values than the other measure of center we want to use. The other measure of center we want to use in the case of skewed distribution is a compromise between the mode and the mean, and it's known as the median. The median does not take into consideration the value of the extreme observation. All it cares about is the more regular portion of the distribution in the middle. It is actually in the middle. It is where the ranked observations are cut in two. So the ranked observations on the left of the median amount to 50% of the observations, and the ranked observations on the right of the median comprise 50% of the observations. So it cuts right through the ranked observations. Now we can calculate the median using Excel as well. But I'd like to show you how to do it by hand. So let's see, I can get it in Excel. Let's see, let's use Excel. So that was the mean. Let me put a column in here. Oh, that's not what I wanted to do. Sorry, this is different than I'm used to. I've not used this on my iPad. Why can't I? Just want to insert a column. Okay, I have no idea. Okay, let's try that. There we go. So this is the average. And this is the average. But I could also use Excel to get the median. I'm going to do the same thing with median. I'm going to highlight and drag down and close the bracket. Notice the numbers are similar but slightly different. Let's get the median here. So these observations will be in the same class, right? 43 or 44 hits and 46 will be in the same class. And similarly, these numbers will be in the same class. They're very similar, actually. Yet, the rule is, let me calculate the median by hand to show you how we do it. So if I want the median for Maris, what I do is find the location of the middle observation. Now, some of you may have learned, oh, I lost everything. Don't want to erase everything. I just wanted to I'll use the one above. So what you do is you can physically find the center by crossing out one on each side until you get into the middle. Now there's two in the middle this time. So the median, when you have that case, when you have an even number of observations, you end up with 2 in the center. The median is found at the average of the 2 in the center. That's how you find. Let me write this. Okay, the median is the average of 23. Oh, you don't see that. Let me make it visible. That doesn't work. Oh dear, I have to clean all of this. That didn't work. What am I doing? There we go. And then, not working. Sorry. All right, I will just move this down and move some parts. Since I moved. No. Okay, can you see that? There you go. The median is found at the average. So I have to add those and divide by 2. Gives you 24.5. Is that what we got in Excel? Yes, we did. It's right here. Okay. So that is the median for mayors. That's one way to do it. Another way to do this calculation, so I've shown you on Excel, I've shown you how to manually do it. Another way to do this, let's say if you had a large data set and it's not feasible to do this, crossing out on both sides to approach the center observations. Before I go on to that last method, I just want to point out, to calculate the median, notice we just used the middle two observations. I didn't include any of the other numbers in my calculation. That's really important. Okay, so it just focuses in on the middle. Now, the other way to calculate a median is to use the rule again, this is all in the notes. I'm just using the properties of the notes. So the n+1 observation, or over 2 observation, is where you will find the median. Turn things up. Okay, so where are we gonna find that? The number of observations is n for Maris is 10. So the median is at the n+1 divided by 2, or 11 divided by 2, or the 5.5 position. So where is that? 1 in the ranked data. 1, 2, 3, 4, 5.5. You see? So it brings me to the same place. All right, so the median for Maris is the 24.5 observation. 24.5 hits. So the question is, should I be using 24.5 hits or 26.1 hits to represent the expected value? The convention is, when the data are skewed, we use the median as the expected value, or the measure of center. And I put a box around this in the notes, so you will see. The median for a right skewed distribution will always be smaller than the mean. The mean will be distorted by the extreme values. So So it will be closer to the extreme values than the median. That's always the case. So when data are skewed to the right, the mean exceeds the median, and I've written it down here as well. It will be, the mode will be smaller than the median will be smaller than the mean. Because the mean value uses all the values and it's pulled, distorted by the extreme values. Similarly, for left skewed distribution, you'll have the mode here, that's the peak, the modal class. The mean will be skewed towards the extreme value because it uses all the observations in its calculation. But the median will be in the middle. So it's a compromise between the mean and the mode. And the convention will always be to use the median as the measure of expected value when data are skewed. So what you'll hear is, in instances and variables that are summarized, with, and they're found to have a few extreme values, like income, right? You often hear about the few wealthy households, the 1%, and then everybody else. This will create a skewed distribution. So for incomes should always be reported, the median should always be reported for incomes. And you will hear that in news reports, or you'll read about that in the press, median income. You'll hear about median income more than you'll hear about average income, depending on the context, but that's how it should be done if the data are skewed, if you have a few outliers here. If the data are symmetric, it doesn't matter, but the convention tends to be to report the mean. Since the mean and the median and the mode are all the same thing, it doesn't really matter, right? But it's often the mean that you hear about. Now, if you were to put these numbers in computer software that did statistical analysis, the computer, unless it's highly sophisticated, will just make a multitude of calculations, and it's up to you to choose the ones you need. You'll be given the mode, the median, the mean in some software, and you have to pick the right one. So this is why I'm teaching you which is the right one. When data are left skewed, what you have are a few extreme values that are small. Okay, you have a few small, extremely small values. So one instance, I just made this example up. Maybe school grades completed. This is the proportion or the number of people that have completed grades, lower grades all the way to the upper grades. Most people have some education, grade, depends on the region, but some decent level of education, respectable level. Some will go as far as to graduate from a college, and then you have people who've done more than that. I said grade school, so maybe if we talk about a population where most people have, let's say, a grade 6 education, several people have up to here. We could say this is a grade 10 education, and then The rest go on to complete. It's less likely to complete, but at least grade 10 is most frequently completed. And there are just a few that don't have any education for different reasons. Maybe they're not capable as an adult. So if I did this study on adults, there's just some that didn't get any education because of particular cognitive challenges. Okay, so here's the rule. In conclusion, we report the mean as the center of symmetric data and the median as the center of skewed data. I go on to talk about other measure of center, but this is just a special case in finance and economics that we use. But I'm really concerned for this course with the other three, okay? This is more like an example, another kind of center of a distribution. Okay, so back to our 5 features. So we've done that. We've calculated the mean for Ruth as this measure of expected value, and we've calculated the median and the mean as well, but we're going to pick this one for our report. Next, what we're going to do, and we can also summarize that, rounding it up to 25 hits, and we still see that Ruth is a much better baseball player, right? In terms of expected value, you would predict higher hits than you would for Maris. Okay, now what I'm going to do is talk about the third feature. The third feature is known as the spread of the distribution. The spread captures the range of values, and so often when we talk about spread, we will mention the range of values. The values for Ruth fall between 22 and 60, and for Maris, the values span over 8 to 61. We can calculate a range, calculating max minus min, and do the same thing for Maris, and it gives me an idea of how spread out. I want to move this bit. Okay, so we're going to take 60 minus 22. Gives you 38. So this is going to be less spread out than 61 minus 8. Okay, so that demonstrates that it's tighter. This is a tighter distribution. So that's one thing we can do with the spread. The next thing we can do Oh, and I can comment. I can make some tight, regular distribution. And for Maris, you can make the comments that I made before, flat, and say volatile. I don't know if that's volatile, but it's not wild difference. It's just one extreme value. I'll just say uncertain. Okay, so those are some adjectives for the spread. And then finally, what you can do is calculate a summary statistic. A summary statistic for spread, like a summary statistic for center, depends on the shape of the distribution. That's because the spread measures will use the center measure in their calculation. And the center measures being affected by the shape means that the spread will also. So when data are symmetric, what we use is called the standard deviation. And in the videos that I have prepared for you, I'm going to teach you how to compute the standard deviation. I'm not going to carry it out here. You can watch that. You should watch all the videos. I'm expecting you to. And you're going to calculate it in the case of a symmetric distribution. You can get it in Excel, which let's do that. Nice and easy. You see, I can add it on. Sorry, for Ruth. And the notation for that is STD. See, they pop up here for you to see them. Easy. Again, you select the range of values. And there it is. Standard deviation is 11.25. Okay. I'm only doing this for Ruth. Why am I doing it only for Ruth? What did I get? 11.25. Or I can make it, oh, I'm running out of space. I'm going to move this thing up. So this is about 11 hits. Now what do I do with that? Well, okay, first of all, let me tell you what the standard deviation is. The standard deviation looks like this. And when you watch the video, I explain how it's calculated and why it's calculated that way. The main thing you need to see here, why I've written this, is to make you see that the standard deviation calculation depends on X bar, and since the sample mean. Since the sample mean is part of S, then the same problems inherent in the sample mean will affect S. In this case, there's no problem because the sample mean is used as the expected value, so we can use S as the measure of spread. And we can conclude, this is what we do with these values, is we say, most of the time, Ruth hits 44 home runs, give or take 11. Mathematically, what I mean is 44 plus or minus 11. Or a range, most of the time, he gets between 33 and 55. That's how you use the mean and standard deviation. Remember, we use them, calculate them when there's a symmetric distribution, so we can exploit their measure and say, we expect 44 hits, but standard deviation is a measure of how the other values spread around the mean. So they deviate away from the mean. So I'm going to add 11 and subtract 11 from the mean. The higher the standard deviation, the more spread out or flat the distribution. In this case, most of the time, he's got between 33 and 55 home run hits. Now, I can't do that for Maris. In the case of Maris, we make another statement when the data are skewed. We use what's called the 5-number summary as the measure of spread. Okay, we do not use standard deviation. So you need to remember that. So what's the 5-number summary? The 5-number summary looks like this. And let me make a title. 5-number. All of this information is in the notes. I'm using it. I'm doing it like an overview right now. It consists of the minimum value, Q1, the median, Q2, whoops, what happened? Come on. Oh, I hit something. Okay, and the maximum. So what do these mean? Minimum is the smallest value. Q1 means the first quarter. Or that's where 25% of the observations are below this value. Remember, the median is actually Q2, the second quarter. 2 quarters is 50%. So 50% of the observations are below this value, the median. And Q3 is where 75% of the observations are below it. Does that make sense? So how do I do this? So what do? I return to my data. And now what I want to do, again, this is just for, I'm just going to do this for Maris, because I don't need to do it for Ruth. Let's see if I can erase this to make space. I don't erase all that. Okay. So we found the median we found, oh, I didn't want to do that. We found the median. The median divides the data in two. So now I have this data set and this data set. So this is the lower 50% and the upper 50%. What I want to do next is find the middle. Let me reproduce the numbers. I want to find the middle of the lower 50%, and that will mark the 25th percentile. So you can see it here. You can clearly see that this is the middle, and that's the middle. So this actually is Q1, and this is Q3. And we call the median Q2, where this is the minimum value, and this is the maximum value. So that's all it is. That's all it takes. Now, I did some calculations in the notes. When you have a large data set, you want to use that rule n plus 1 over 2, right? So what you would do is take here, the n changes. It goes from 10. Now we only have 5 observations. And you would find the position where 5 plus 1 over 2 gives you the middle observation. So that would be the third observation, which happens to be where we found the middle. 1, 2, 3 in our case. And similarly, the same thing applies over here. Third observation. Okay, so I just applied the rule n plus 1 over 2 to find the middle observation. So what we have are the numbers, the values we need. We have the min, we have the max, and we have the Q1, Q2, and Q3. All right, so let's put them down. What did I get? I got 8, 14, 4.533. So I'm going to write them now. And I need to use the value I compute, 24.5. Was it 33? And 61. That is the 5-number summary. What did I just do? Let's go back a page. Right, 33 and 61. Okay, that's called a 5-number summary. All right, so those are the 3 features. There's 2 more. Before I continue, let me see if I'm going to use, I'm going to check, I have to check the sound. I'm worried that my AirPods are going to lose power. So let's see, I think my microphone works just fine. I'm going to check it. Somehow I didn't plug it in properly today. Or yesterday. Whatever day it was that we started.
Okay. Test, test.
Okay, I'm going to check the sound. I think it's working. Okay. So what the other thing we do with the 5-number summary before I continue is compute what's called the interquartile range. The interquartile range, or the IQR, is the range of the middle 50% of the observations. So it's between Q3 and Q1. So it's the range of values between Q3 and Q1. So it's equal to 33 minus 14. Which is 19. So it's equal to 30. Yes, that sounds good. Okay. We need that because we're going to use that. So what that says is, although the range of values was 58, right? It was very spread out. The middle 50% of observations is only 19. So it's giving you an idea of the regularity within the distribution. So Q3 would take us, remember, looking at the pattern here, it didn't come down. Oh, how do I get that? No, it got split. Darn. Okay, if you remember the pattern of the distribution, this would capture the hump, right? The hump of the data, 33 to 14, between there. And it ignores the extreme value of 61. So that captures the regularity and ignores the curiosity, which is important, because to make predictions, you have to look at the regular portion. With awareness of the possibility of its extreme values, you have to be aware of them, but the regularity is where you expect things to happen. Okay. Before I continue, I want to use stat mode in my calculator to calculate the mean and standard deviation for Ruth. I already have the values. I got 11 for the hits and 44. So what I did was I calculated X bar plus or minus S to get this range of values of what to expect, right? So let's use stat mode in the calculator. All right, so I'm going to use the BA2 Plus, and in the videos edited, I use a different calculator. But you have Excel also. Right, so let me try this in the BA2 Plus. I'm going to pull up the values, and this is for Ruth. Here's my calculator, and I'm going to show you in whatever calculator you have, you should be able to locate a data button. Mine is here. If I use second function data, I'm in data mode. Now I already had something in there, so I need to clear it out. So I'm going to hit second clear work. So it wipes out what was in there. Then I'm going to begin entering values from the raw data set. So I enter values, I enter the first observation. So this X represents the observation and the number 1. So the first observation is 54. And I say enter and push the arrow down in this case. Now it's asking me for a second variable. Because this calculator conducts two variable statistics, I can enter two variables in pairs, or values in pairs for two variables. So I'm not going to put anything in there. I only have one variable, so I just go down again. I continue with 59, enter down, and I hit down again. Then 35, enter down, and then 41, and 46. Oh, that was wrong. 46, enter down. So this enters the values like in a worksheet. 25, enter down, down. 47, enter down, down. 60, enter down, down. 54, enter down, down. 46, enter down, down. 49, enter down, down. 46 again, enter down, down. 41, enter down, down. 34, enter down, down. And 22, enter down, down. So I'm done. I'm finished. I'm not going to enter a 16th value, and I'm going to ask for stats. And what it tells me is it's going to give me the results for linear regression, which we will learn about next week. That's what LIN stands for. So what I'm going to do is use the down arrow. It tells me that there are 15 observations entered. The mean is 43.93. I already knew that. Remember, we rounded it to 44. And then it tells me the standard deviation is 11.247, which I already know as well. So that's the easy way to get those from your calculator. There's another measure here. If you remember the symbol, this is the symbol for population standard deviation. Now the calculator doesn't know the nature, the context of the data you've entered. So it could be that you enter data that you believe is a census or population data. So if that was the case, it's a different formula. And I do discuss that in the videos. It's a different formula that we would use, similar, but slightly different. And you would have to use this calculation. But we're using the sample standard deviation. Sorry about that. The sample standard deviation calculation, and that's S, right? So we're going to, you have to watch that again. Watch that video again if you didn't get it. But that's how you get the mean and standard deviation in stat mode. All right, so I'm going to move on to the fourth feature. The fourth feature of a distribution is called gaps and outliers. And it turns out for this symmetric tight data set of Ruth, there are none. So I'm just going to say none. There's no gaps in the data set, right? And there are no outliers. However, in Maris's data set, I'm going to go and pull it up. I'm going to try and bring it down here. Oh, it's way up there. I have to shrink this. Not easy. Well, let me see if I can get it from somewhere else. Should I draw it somewhere else? Nope. Oh yeah, maybe. Nope. Well, I'm going to reproduce it. Did I have it there? Oh, I have it here. Okay, let's take it from here. Sorry. This is hard to look at. So this was the distribution for Maris. Right? And what do we see? We see gaps here. Right? There are two classes that there's no data in, the 40s and the 50s, and you see here an outlier, a value that sits apart from the rest of the data. So we need to mention the two gaps, and we need to test if actually this outlier meets the conditions of a statistical outlier. Okay, so when you have an outlier, it begs investigation. You need to first verify that it is different from the rest of the data, and then if you find it is, you have to determine why. Is it possible that there was a data entry error? Is it possible that there was a measurement error in trying to compute or record? There was an error made in actually measuring that value. In this case, I'm not sure how that could be, but in other instances, like measuring the speed of light, there could have been an error made. So first we got to verify that it's a strange and statistical anomaly, and then we can talk about what to do about it, because it does distort our statistics, so we need to mention it. Okay, so let's write this up. Let's see what I can do. I'm stuck again. Let's move this away. Go away. And I'm going to write for gaps and outliers and say there are gaps in the classes of 40 to 49 and 50 to 59. There's no data there. And for outlier, we need to check. Now I have to show you how to do that. So to check for an outlier, we're going to verify. What we do is we take the 5-number summary, the value of the third quartile, and we add 1.5 times the IQR. So what am I doing here? What I'm doing is I explain this in the video, so you'll take some time to review that, please. What I'm doing is taking the regular spread of the data and using it and saying if observations are beyond the third quartile, like 75% of the data has already been seen, if there's data 1.5 times the IQR away from the third quartile, then we'll call that strange or an outlier. Okay, so that data would be considered outlier data. That's the rule. So this is called the 1.5 times IQR rule. Not a fancy name at all.
So what we're going to do is take 33 plus 1.5 times 19. So that's going to be 33 plus 28.5, which gives us 61.5. So what does this mean? Any observations, let me write it above. So outliers beyond 61.5 are considered, observations beyond 61.5 would be considered outliers. In our case, there are no outliers, no statistical outliers. So we checked, and there are in fact no statistical outliers. Now we did it this way because the extreme value was on the right. Now the extreme value could be on the left, but not in this case, doesn't happen. So we just check on the right. If there was an extreme value on the left, you would have to check Q1 minus 1.5. So you're going to use the first quarter and see if there's any values far away from that edge. So you would check the left of this calculation. So I said, in the videos that you'll watch, you'll see this explained more in detail. So what did we find? Even though we found that we have that extreme value, it turns out that in statistical terms, it's just on the fringes of being a statistical outlier. It's still strange and worthy of investigation in my opinion, okay? And you would have to see if there was any